This video is on the combined gas law. So this combines a few others, hence the name. So the variables in this are pressure, volume, and temperature. So our only constant is moles. So our equation, when we put these together, is P times V over T equals a constant. So if we look at the equation format, it would look like this, where pressure times volume over temperature equals pressure times volume over temperature. And we're not going to write down anything for the relationship right now, because you're going to see as we do the problem, we're only going to focus on one variable at a time. So let's actually write that down. All right, so in our problem, all right, let's see, a certain gas occupies a volume of 550 milliliters, 27 degrees Celsius, and 750 millimeters of mercury. So there's our volume, temperature, and pressure. What volume will this gas occupy at STP? Now, if you remember back from a previous video, STP stands for standard temperature and pressure. So that is telling us a temperature and a pressure. All right, so just like before, let's make our chart with everything in it. And it doesn't matter the order you put things in, but we're going to list them all. Okay, so our volume initially starts at 550 milliliters. The temperature is 27. Now remember, we have to add to our 273 to turn it into Kelvin. So it's 300 Kelvin. And our pressure is 750 millimeters of mercury. Okay, so what volume? So that is our unknown. And standard temperature. Remember, standard temperature is 0 Celsius, which would be 273 Kelvin. And standard pressure is 1 atmosphere, but we don't want atmospheres because we have millimeters of mercury as our other pressures. So 1 atmosphere equals 760 millimeters of mercury. All right, so we're going to set it up just like before. I'm going to start with my unknown, so 550 milliliters. Now I'm going to set up 2 conversion factors, but I'm just going to deal with one at a time. So I'm going to look at my temperature, let's say first. My temperature goes from 300 to 273, so my temperature decreases. Now volume and temperature have a direct relationship. So as one increases, the other increases. It does the same. So if temperature decreases, that's going to make the volume decrease. So I'm going to set this up as, and I'll do this one in red, to make it go down, my smaller on top, 273 Kelvin over 300 Kelvin. Okay, so that's dealing with my temperature. Now let's do the pressure. Okay, so ignore the temperature now. So pressure goes from 750 to 760. So pressure increases. Now pressure and volume, that's Boyle's law, have an inverse relationship. So as one goes up, the other goes down. So as pressure increases, volume decreases. So this is going to be, to make it decrease, the smaller on top. So 750 millimeters of mercury over 760 millimeters of mercury. So I've dealt with each one individually. I'm not looking at overall, is it going to go up or down, because they could each make them go opposite, and it's going to depend on the value of your conversion factors. So when I do my math, my Kelvin will divide out, my millimeters of mercury will divide out, and my answer with 3 sig digs will be 494 milliliters for my volume.